Welcome, ladies and gentlemen, to your video lesson on 12.1. This is all about creating and solving systems of linear equations, which was something we've been working on for a while. This entire lesson is contextual, meaning it's all about real-world situations. And so there are 7 examples in this lesson in which we will go through how to read through the situation, set up a system of equations, and solve. In the beginning here, we do have a warm-up, so hopefully you have that completed already. If you do not have that completed, I would suggest you try that now because elimination and substitution are going to be all through this lesson, and you have to know how to do it before we move forward. So go ahead and practice it, pause the video, try it. All right, hopefully you tried that. So I'm going to go through the elimination one. So remember, in elimination, our whole goal is to add the variables vertically, right? And so we have to first make sure our x's are lined up and our y's are lined up and our equal sign are lined up. And that's true in this case. But if we look at it right now, we notice like the x won't cancel out because negative 4x minus x is negative 5x. And minus 15y plus 5y, again, doesn't cancel out either. And so what we have to do is manipulate this. So what I'm doing is, I want my different marker here. I'm going to take, no, that's not what I wanted either. Hold on a second. I got to get rid of some stuff. To this page bunch. Go back up to the top. All right. So what I'm doing is I'm taking that second equation and I'm multiplying it by a negative 3. So it's kind of looks like this, right? Multiply by negative 3. What I have to make sure is that I don't just multiply what I want to be opposite, right? The y's here. If I multiply by negative 3, I'll get a negative, positive 3. If I multiply by a positive 3, I'll get a positive 15y here. But I have to multiply everything, right? So this, and this all gets multiplied. I end up with a negative 3x, a positive 15y, and a negative 39. Now when I add vertically, I end up with a negative 7x. The 15y's cancel out. One's positive, one's negative. And I get a negative 56. Divide both sides by negative 56, and I get a positive 8 for x. So moving on to the next step, now that I know that x is equal to 8, I can substitute it into any of the top equations that I have here. So I'm choosing the one with 5y. So negative 8, or the opposite of 8. One thing you have to pay attention to here is this is a negative sign, right? So I'm substituting in a positive 8 in for x, but that sign can't disappear. So it's right here. So the opposite of 8 plus 5y equals negative 13. Adding it to both sides to solve gives me negative 5. And if I divide by 5 to solve for y, and I get y is equal to negative 1. So the solution to my system is 8, negative 1. All right, so that's a review of elimination. Substitution now. Remember, in substitution, we first have to have an equation solved for a variable, meaning we have to have x equals something, and we have to have y equals something, one or the other, not both. In this case, I know that y is equal to something. It's 3x, or negative 3x plus 7. So that whole expression is going to be substituted in for that y. So when I do that, remember I have a big distribution that I have to do. That's not big, it's just 2. But I do have to distribute. So I have the 2x here, and then 4 times negative 3 and 4 times 7. When I do that, I get negative 12 and 28. Kind of going on here. I can combine like terms, so the 2x and the negative 12x give me negative 10x. And then I will subtract 28 from both sides to get negative 20. I'll have negative 10x is equal to that negative 20. Divide both sides by negative 10, and I'll end up with positive 2. So I get x equals positive 2. Then I use that to solve for y. So I think it's pretty clear that the best equation to substitute that back into is the top one. So I'll do that. So y is equal to negative 3, and instead of x, I have 2 plus 7. Negative 3 times 2 is 6. Negative 6 plus 7 is 1. So I get the solution of 2, 1. Remember, this is where, if we were to graph, these two lines would intersect. And then the last warm up here, this is the graphing one. This is the third method that we've talked about for solving system of equations. I'm going to do this one with you. So the y-intercept for this one, remember, is the number all by itself. So that's -4. And it's y-intercept, so we're putting a point in the y-axis. So that's going to be right here. Then my slope is 1/3. That means I go up 1, right 1, 2, 3. Up 1, right 3. Can't go any further this direction. Now I have to use it exactly backwards to go the other way. So down 1, left 3, down 1, left 3. I'll try to draw this line as straight as I can. Oh my goodness. You get the idea. So there's my line. Then this one is in standard form. So I could solve this for y to make it look like the top one, but instead I'm just going to show you the intercepts method again. Remember the intercepts method, if you want to find an x-intercept, meaning where does the line cross the x-axis, we substitute y in for 0, or 0 in for y. So you're going to see me doing that here. So if I substitute 0 in for y, 6 times 0 just goes away, right? And so it's because it's 0. So I'll end up with 4x is equal to 12. I divide both sides by 4, and I get x equals 3. And my coordinate point ends up being 3, 0. And you can already see the y stuff. If I'm solving for a y-intercept, 0 goes in for x. And so 4 times 0 is just 0. So I'm left with 6y equals 12, which is what is there. So I'm dividing both sides by 6. I get y equals 2. So my coordinate point is 0, 2. So now I'll plot those. 3, 0 is right here. 0, 2 is right there. And in order to get from one point to the next, I'm going down 2, right 3. So I'm going to keep doing that. Down 2, right 3. And there's my point. So the solution to this system is right there. And it is the coordinate point 6, -2. Okay, so that's a review of all of our solving using elimination, using substitution, using graphing. Now, when we go through these word problems, we're really only going to focus on the elimination and the substitution. That's just what we're going to do. We're not providing you with graphs for that. But graphing is also a solution. Remember, though, that graphing can be inaccurate, right? First of all, look at my wonky lines, right? Maybe my line isn't that great. But also, if I get an answer like the decimal value and they intersect somewhere in here, right, we have to make an interpretation that we don't know for sure exactly what that number is because we're graphing it, right? So that's where these other methods are more accurate. So again, 12.1, now we're going to be starting to work through that. The whole thing is about creating and solving systems of linear equations from word problems. So let's dive right in. This is going to follow kind of a certain method. So I already have these all worked out. Everything's behind shades. I'm just going to talk through them as we see it. So after leaving her hotel, a student is walking to a cafe to have breakfast and do some sightseeing. On the way, she passes 2 stores that rent bicycles. The first shop charges an initial fee of $7 and then $2.75 for each hour after that. The second store just charges a flat fee of $3. There is no initial charge. Well, for breakfast, the student needs to decide which rental agency to use. This is something that you might come across all the time where you were like, well, I want to know if I rent it for this amount of time, what's cheaper? If I rent it for this amount of time, what's cheaper? And what point will they be the same where it doesn't actually matter who I rent it from? And so that's kind of what we're getting at here. So the first thing we're going to do is define our variables, right? So we're going to say that X is the number of hours that this person's renting it, and Y is the total cost of the bike rental. All right. The first thing says for the first shop, what is the initial cost? So the first shop's initial cost is $7, but then they charge $2.75 per hour after that. So that's the cost per hour. The other shop, oh no, sorry, for part B, we're going to write a linear equation. So the total cost, which is Y, is going to be equal to that 2.75 times the amount of hours, which is what X is, plus the $7 initial charge I have to pay no matter what. So this is for shop number 1. Okay. Then for the second shop, what's the initial cost? There isn't any, but they do charge $3 per hour. So the second shop is actually more expensive per hour, but they don't have any upfront charges. The other one is a bigger upfront charge, but it's cheaper per hour. So you might want to decide which one you're going to use. So we're going to write a linear equation that represents the cost to write from the second shop. So bike shop number 2 has no initial charge, so it's just the cost is Y equals 3 times X, and X is hours. You can write plus 0 if you like, but it really doesn't add any numerical value to the equation. Now that we got our 2 equations, we're going to go to E and we're going to set this up. These are our two equations that we came up with before. I think I had the 2.75 flipped around, but it doesn't really matter. Same thing. And whenever we're doing these, we have to kind of ask ourselves, like, what is the best method? We already said we're not going to really do graphing here. And then if you look at this, like this has a slope of 2.75. That's not a great slope to graph to begin with. So that means we have to choose between elimination and substitution. And this is set up perfectly for substitution because I have an equation solved for a variable in both, which means I can take this 7 plus 2.75x and substitute it in for y. So I know that y is equal to 7 plus 2.5x. So I can substitute it in for y into the other equation. That's exactly what I did. I did it in a little bit different order. I mean, it doesn't make a difference. It can go this way or that way. So in any event, I substitute that value in. I get 3x is equal to 7 plus 2.75x. I got to get my variables on both sides. It's always the best to subtract a smaller number so that you get a positive result. So I'm subtracting 2.75x from both sides. That gives me 0.25x is equal to 7. I'll divide then both sides by 0.25. 7 divided by 0.25 is the same as multiplying by 4. I get x is equal to 28. So now I know that at 28 hours of rental, they will cost the same amount. Okay. Now, how much is that going to be? Well, I have to substitute that x back into one of the equations. And it doesn't matter which one. It can be the top or the bottom. I'm going to choose the bottom because it's the easiest. So if I'm going to substitute that 28 back in, it's y is equal to 3 times that 28. And that'll give me, let's go a little bit more, 84. So what that means is it's going to cost $84 after 28 hours of bike rental. So now you can make an informed choice. Let's try to save money if you can. All right, so example number 2 is really just getting at the point, what is the best method to solve, right? Is it graphing, elimination, or substitution? So I'm looking at these, I would say either, I'm going to just abbreviate, I'm going to say graphing or elimination, okay? So I'll maybe color like G, substitution or elimination. Graphing is substitution, elimination. I would say graphing or substitution. I wrote an E here. I really wanted a S for substitution because slope-intercept form is easy to graph, right? And substitution means I can take this and substitute that into the other one. That would work. This one is also substitution or graphing because I have a variable solved for itself, an equation solved for a variable, so I can substitute that in for y here. I could also graph this pretty easily as well. I would say that this one here is best set up for elimination because I could the x's to cancel out right away. I would also say that the last one is best set up for elimination because even though they won't cancel out right away, if I multiply, say, the bottom equation by 3, I would get the 9s to cancel out because I would have a negative 3y and a positive, negative 9y and a positive 9y. Or I can multiply the bottom equation by 4 and get a negative 4x and a positive 4x. All right, question number 3 about streaming services. So video streaming service Atomic Stream charges $10 for a membership and $1 for each movie that they download. Blitz Video charges $15 for a membership and 50 cents per movie. How many movies do you need to download for the services to have the identical cost? It's like the same type of situation as before. We want to know when it doesn't matter about how many movies I rent, and it'll cost the same, and then we can make a decision based on that later. All right, so define your variables. We're going to let x equal the number of downloads here, and y is equal to the total of cost. So I'm going to write an equation that is for Atomic and for Blitz. So for the Atomic company, they charge $10 no matter what. So that's my 10 right there. And I'm adding to that cost $1 per movie I download. So that's where the 1x comes from. Then the Blitz is total cost is y is equal to 0.5 times the number of movies plus their initial charge of $15. So those are the two equations based on what we read. All right. So now I'm going to use substitution on this one as well. I have equations solved for variables. So I'm going to take this 0.25 or 0.5x plus 15 and substitute it in for y there. until you can see them equal to each other. I'm subtracting 0.5 from both sides, 0.5x, so I can get a positive result. That still gives me 0.5 on the other side. So I end up with 0.5x. Now I'm going to subtract 10 from both sides, get a 5 on the left. 5 is equal to 0.5 at this point. I'm now going to divide both. I ran out of room here, so I didn't show the word for it, but I divided both sides by 0.5, and x is equal to 10. So that means the amount of videos that it'll take for, or amount of movies it'll take to download to get to the same cost would be 10. Now I want to know how much that's going to be. So I take that 10, substitute it in for any equation. I chose the top one here because it's the easiest to me. 1 times 10 is 10, 10 plus 10 is 20, and so we get 20. So when will the video streaming services cost the same? It's going to cost the same after 10 downloads, and it'll cost $20 each. All right, on to the next one. So George, he had $4.50 worth of quarters and dimes in his pocket. There were four more quarters than dimes in his pocket. Find the number of quarters and dimes. So on the outside, this one, it's like, how in the world are we supposed to write equations? Well, there's somewhat hidden information in here. Like, we know what a quarter costs or is worth. We know what a dime is worth, and we know how much money is in his pocket. So that's where one of the equations is going to come from. The other one's going to come from this statement right here, saying that there are 4 more quarters than dimes in his pocket. So let's break it down. So we're going to let Q be the number of quarters and D be the number of dimes. Right? So those are the two variables. And then we're going to write a term that would represent the number of quarters times the value of a quarter. All right, well, if Q is the number of quarters and the value of a quarter is 25 cents, so it's 0.25Q. Write a term that would represent the number of dimes times the value of a dime. Same thing, 0.1 times D, because D is the number of dimes. And a dime is 10 cents. So now we're going to write an equation that would represent those two terms added together to equal the amount of money in his pocket. 0.25Q plus 0.1D equals 450. Last one, we're going to write an equation that represents the fact that there are 4 more quarters than dimes in his pocket. That's going to be D plus 4 is equal to Q. And now we're going to use those two equations to solve the system. So here we go. Here's my system of equations. I know that Q is equal to D plus 4, and I have kind of a standard form equation in the top. So if I have an equation that is solved for a variable, I'm going to take what I know that variable to be and substitute it into the other equation. So Q is D plus 4, so I'm going to substitute that here, and you see me doing that at this point. So I would have to distribute that 0.25. It gives me 0.25D plus 0.25 times 4 is 1. It's like a fourth of 4, which is 1. And then the rest of the equation still remains. Now I got some like terms to combine here and here. That gives me 0.35D plus 1. I'm going to subtract that 1 from both sides to get 0.35D is equal to 3.5. Divide both sides by 0.35, and I get D is equal to 10. So that's the amount of dimes in his pocket. Okay, now that I know the number of dimes in his pocket, I can use any of the original equations. I think this one's obviously the easiest. All I got to do is add 4 to that. So Q is equal to 10 plus, I think I had the wrong number here, don't I? I do. But the funny thing is, I think I have, nope, okay. So here's the deal. I wrote 3. It should have been 4. Oh, well. So it's the number of dimes plus 4, which is what the equation was, right? So 10 plus 4 is not 13, it's 14. So we can say that George has 10 dimes and 14 quarters in his pocket. All right, you need to watch that again. Go back. So in your packet, you have G and H here. I kind of did that all on the same page. You can get that information from the last one. All right, question 5. There are a total of 56 students in Mr. Bratz's FST class, which is made up of juniors and seniors. The number of juniors is 5 more than twice the number of seniors. Find the number of juniors and seniors in the class, right? Solve a system of equations to find your variables. So this sentence right here is where we're going to get our first equation from. We know that there's juniors and the seniors that make up 56 students. And then the other equation is going to come from this. Juniors is 5 more than twice the number of seniors. So let's break it down here. I guess I didn't write this. It said define your variables. I think it's pretty clear that J is for juniors and S is for seniors. So that first sentence, J plus S equals 56, that just comes from juniors and seniors make up 56 students in the class. The second sentence, or the second equation, comes from this sentence right here. So it starts off by saying juniors is, right? So it's going to be J equals. Juniors is J equals. Then it says 5 more than. Whenever I think 5 more than, I think 5 more than what? I'm starting with something and I'm adding 5 to that. So what am I starting with? It says twice the number of seniors. Well, twice the number of seniors is 2 times the number of seniors, and the number of seniors is S, so it's 2S. And then I'm adding 5 to that because it's 5 more than twice the number of seniors. So I got my 2 equations. Again, this is kind of the same as the last ones we have. We have an equation that is solved for a variable. So I'm going to take that and substitute it into the other equation. The 2S plus 5 is going in for J in the top equation. So here we go. There's the 2S plus 5 being substituted in for J, plus S equals 56. Got some like terms combined here. 2S plus S is 3S. 3S plus 5 equals 56. Subtract 5, divide by 3, and we end up with S is equal to 17. So now that I know that S is equal to 17, I can substitute that into any equation. It can top or bottom, doesn't make a difference. I'm not sure what I did. I used the bottom equation. 2 times that 17 is going to give me 34. Add 5 to that. That gives me 39 juniors. So in Mr. Brough's class, there were 17 seniors and 39 juniors. Oops, a little bit too far there. All right. Question 6. Kelly went to the store to buy bags of chips and soda for a birthday party. A bag of chips cost $3, and a 2-liter bottle of soda cost $2. At the checkout, she had 14 items in her cart. We don't know specifically how much of each one. 14 items, though. And the total cost was $34 before tax. Find the number of bags of chips and 2-liter bottles of soda in the cart. So we're defining our variables to start, saying that B is the number of chips and S is the number of sodas. So we're supposed to write a term that would represent the number of bag of chips times the cost of the bag of chips. And B, we ended up with 3B here. So B actually is not the number of the bag of chips. Actually, for this, we should have 3B. I don't know why I thought that was. I was thinking something else. 3B. So it's $3 times the number of bag of chips. Then write a term that represents the cost of soda. Cost of soda is $2. S is the number of sodas, so it's 2 times S. So 3 is the amount of money, 2 is the amount of money or cost for each one, respectively, for bags of chips and soda. So that's how we get the 3B and the 2S. Now we're going to write an equation that represents the total cost of the bags of chips and the soda, but then also set it equal to the amount of money that we spent. So that's going to be 3B, $3 times the number of bag of chips, plus $2 times the number of soda bottles, equals the $34 that they spent. So that's equation number 1. Then we're going to write an equation of the number of bags of chips and soda equal to the number of items in the cart. Well, if we remember, there were 14 items in the cart, which is stated right here, right? And so if B is the number of bag of chips and S is the number of sodas, that means we can take B plus S, and it should be equal to 14. So now we got our system of equations. So I kind of broke this in 2 parts. So this is the original system. The 3B plus 4S equals 34, and the B plus S equals 14. So this one would be clearly an elimination because the variables are lined up. So I'm going to do that. However, when I try to add these vertically, I won't get a variable to cancel out. So I'm going to multiply the bottom equation by -3. You can see me doing that here. So I get the -3B plus -3S is equal to -42. So when I add vertically now, I get the B's to cancel out. And I'm left with a -S equals -8. And remember, I can't have a variable solve and be negative. I have to divide both sides by -1. that'll give me S is equal to a positive 8. So that means the number of sodas that she purchased was 8. So now that I know that S is 8, I can substitute that into S into the bottom equation that we used. And so B plus 8 is equal to 14. Subtract 8 from both sides. B is equal to 6. All right, moving right along here. Again, I skipped this page here. So I didn't skip it. All that information is on the previous slide. So you guys can go back in the video and fill it in. All right, I believe this is our last one, then we're done. So at a Friday night football game, the total number of adult and students who attended the game was 970 people. The cost for an adult ticket was $5. The cost for a student ticket was $3. Total amount of money made for ticket sales was $3,950. How many adults and how many students attended the game? Write and solve a system of equations. Define your variables. All right, so I did that, and I said I'm going to make X be the number of adults and Y be the number of students that attended the game. So if I know that 970 people attended the game, my first equation is going to be that X plus Y equals 970. And if I know that an adult ticket was $5 and a student ticket was $3, and all together they took in $3,950, all I got to do is multiply $5 per adult ticket times the amount of adults and add that to $3 per student ticket times the number of students and set that equal to $3,950. So there is that equation. Because these are both in standard form with X's and Y's and equal signs lined up, I am going to add these vertically, but I can't get a variable to cancel out right away. So I'm going to target the Y's and cancel those out, which is why I'm multiplying by -3 right there. Remember, you got to multiply all three things, which is why I end up with a -3x, -3y, and the -2,910. Now, when I add vertically, my Y's will cancel out. I'll end up with a positive 2x, and then 3,950 minus 2,910 is 1,040. So to solve this for x, all I got to do is divide both sides by 2, and I get x is equal to 520. That is the number of adults. So I already know the number of adults was 520. So now I would use this equation, the top equation that we worked with there, to solve for y. I did that. So I'm substituting that 520 in for x right here. So 520 plus y is equal to 970. Subtract that 520 from both sides. And I get 450. So y is the number of students. So that means that there are 520 adults and 450 students at the game. All right, y'all. Hopefully this was helpful. Make sure that you do the independent practice here. Not too many problems. In fact, your independent practice is less problems than we just did. So you should be able to get it done. Hope you guys are doing well. Take care. See ya.